Okay, so the biggest thing that comes out of Algebra 2 is quadratics. And so that is what we started in this unit. We are here until Christmas dealing with quadratics. It's going to show up on the PSAT on Wednesday. You'll see things quadratics, and then a month from now, you're like, oh, I probably could have done better on that question. Okay, so you've seen parabolas before, but it's been a while, but we'll spend a lot of time. And like I said, it's the classical topic. You know, in Algebra 1, the big topic is lines, systems of lines, slopes, like that. Algebra 2, the big topic is quadratics. Okay, so up to this point, we've dealt with linear functions. So if you look at this first one, this is what form of the equation of a line? What's the form of this equation? This is slope-intercept, okay? You look at the next one. What form is that? That is point slope, okay? And you look at the next one. What form is that? Standard form, okay? So just like all of these are forms of the equation of a line, we've got three specific forms for the equation of a parabola that we're going to deal with. Okay, so when you look at these, the clue that this is linear is your variable is x, and it is raised to what power? First power. Okay, that's what makes it a linear equation. Okay, now what we're going to move on to is equations where x is raised to the power of 2. That's what makes it no longer linear, makes it a quadratic. Okay, so now what we're going to do, just like we had slope intercept, point slope, and standard form, there are going to be three forms for the equation of a parabola: vertex form, intercept form, and standard form. So we're going to spend one day on each of those. Okay, so to get this kicked off, let's do a simple graph. Let's graph the easiest quadratic there is, which is y equal x squared. So what I'm going to do here is I'm going to pick points for x and then figure out, so I've already picked those points. I'm going to substitute y equal x squared. What happens when you square a negative 3? 9. Square negative 2. That's 4, 1, 0, 1, 4, and 9. Okay, those are the points. All I did, I take the input value and I square it, and then I need to graph that. So I get the point 0, 0, 1, 1, 2, 4, and 3, 9, and then negative 1, 1, negative 2, 4, negative 3, 9, and you get a graph that looks like this. Okay. Okay, so that's what the graph looks like. This point that you see right here, what is the name for that point? It's the vertex. What is the vertex of this parabola? Yeah, the vertex is the point 0, 0. It's a point, so it's an ordered pair. Okay. Now, if you look at this graph, what does the graph on the right look like compared to the graph on the left? Yeah, it's just a reflection. Okay. So parabolas are symmetrical. So in this case, it is symmetrical about a specific line. So if I look right here, if I were to draw a line right here, I can look and see that it's symmetrical on either side of that line. Okay, what's the equation of that line that I just drew? X equal 0. Okay, so x equals 0, that is called my axis of symmetry. Okay, so whatever the graph does on one side of that line, it does the exact mirror image of that on the other side of the line. What is the domain of this function? Yeah, negative infinity to infinity. What is the range of this function? Oh, wait, so someone might have said it. What? 0 to infinity. I thought you said negative infinity. So it's 0 to infinity. What goes around the 0? A bracket. Okay, so it is included. So the range of this function is 0, 0. So things we need to know is that every time you graph a parabola, it's going to be symmetrical about some line. That line is the axis of symmetry. Okay, this is the easiest one. But what could I do with this parabola? I could move it left. I could move it right. I could move it where? Up, down. What else could I do? I could flip it to where it opens down. Those are all the things that can happen. So we just need to be prepared for how do all of these things happen when we are graphing a parabola. So let's take a look before we get into this formula. If you have a device, you can do that. let's get a volunteer. How about Slade over here on this computer? So, yeah, you'll be good. You can just do it here. So I want you to graph. Oh, you can have a seat there. So I want you to graph in the first line here. I just want you to graph x squared. So just type x and then that capital 6, x raised to the second power. There we go. So what it took me a few minutes ago plugging in points, he just graphed this is y equal x squared. Okay. Now just hit return, go to the next line. Okay, and what I want you to graph now, I want you to graph y equal, let's just say x minus 2 squared plus 1. Okay, so you do parentheses, you have to enter it just like that, parentheses, x minus 2, and then square that. You might have to bring the cursor down with the arrow, and then plus 1. Okay, so now what we have, we've got x squared, and we graphed x minus 2 squared plus 1. What happened? Yeah, it moved. So x minus 2 moved it where? 2 to the right. And then what did the 1 do? It moved it 1 up. Okay, while you're here, just sort of backspace. Make that an x plus 2. Just sort of backspace in there. X plus 2. What did that do? It moved it to the left 2 and up 1. Let me just make this a little, hit a 1. And there we go. So we can see those. Let me do it on the Y as well. Hit the number 1. There we go. Okay. So there we can see it. Okay. So then what would happen if instead of a plus 1, what if you change that to like a minus 3? Yeah, so just make that a minus 3. Okay. So we can see what happened is this one, it moved it to the left 2 and down 3. Okay. What is the vertex of the one in green? What's the vertex? -2, -2, -3. Where did you go? What did you do to find the vertex? You looked at the graph and you did what? Okay. Can you look at this equation and see what the vertex is? Yeah. You said the vertex is -2, -3. So a -2 and a -3 would be there. Okay. So let's hit return and let's do another one. So just like you did this one, let's do something like x minus 4 squared in parentheses. And then move the cursor down and let's just put like -2 or something on it. Okay, so what did this do what we expected? This one moved it where? To the right. Yeah, 4 to the right and 2 down. Okay, so I should be able to tell what's the vertex here. 4, -2. The vertex is 4, -2. What's the axis of symmetry here? What's the line about which this thing is symmetrical? X equal 4. Okay, the axis of symmetry is x equal 4. I can see it here. Is there a clue over here that it would be x equal 4 in the equation? Yeah, you can see that. So x minus 4 is where that comes from. Now, just for grins, before we let him go, come back to the very beginning of that and put a negative in front of everything. Not there. Hit that. Go in front of the parentheses. Now put a negative. What did that do? Yeah. So that was the key to it opening up or down was the negative in front. Okay. So we've got a formula that we'll be doing. Thank you. Appreciate it, Slade. That we'll be dealing with vertex form. So applause for him. And this is what we're doing. So this is the vertex form of a parabola. Y is equal to a x minus h squared plus k. Okay. If you can see an equation in this form, this is vertex form. The reason it's called vertex form, you can look at that equation and tell the Vertex, that's why we call it vertex form. The vertex of this parabola is HK, okay? So the vertex is HK. The line of symmetry, the horizontal line about which this parabola is symmetric, is the line x equal h. If the number in front of this parabola is a positive number, we're opening upward. If the number is negative, we're opening downward, okay? And then this value of a, you know, it's going to multiply. You'll see graphically what that does. It makes the parabola even thinner or thicker, whatever the case may be. So let's look at graphing an example here. So if I look at this, what you might want to do is as many times as you can, you know, you're trying to memorize this formula. It will not be given to you. You're going to need to know this is the formula for a parabola in vertex form. Okay, it's written there. The vertex is HK. What is the vertex of this parabola? It's 1, 1. Okay, this formula has a minus built into it. Okay, x minus h. The vertex is not minus h, the vertex is h. So this vertex is 1, 1, okay? So the vertex is 1, 1. Does this parabola open up or down? Yeah, this one opens up, okay? What's the equation of the axis of symmetry? X equal what? Yeah, x equal 1 is the axis of symmetry. So I know the vertex of this parabola is at 1, 1. So I can plot the vertex, okay? The axis of symmetry, we typically do that with a dotted line. So it's going to be something like this. So we typically would do that with a dotted line. So something like this. That's my axis of symmetry. So what does it mean, the axis of symmetry? My graph, what it looks like on the right of that line, it would look like the identical mirror image of that on the left. We know it opens upward, okay? So all we need now is I need a couple points to know what this parabola does. Does it go way out here? Does it go there? That's what I got to try to figure out, okay? So I just need a couple of points. Now, am I going to pick negative 12 as one of my points to plug in there? No. I'm going to pick points as close to 1 as I can, okay? So I've got this equation is what, so y is equal to, what is it, 2, x minus 1, back up. Y is equal to 2, x minus 1 squared plus 1, okay? So this is the point 1. What's a number that's very close to there that I'd like to pick? 2 is a good one. What's another one that I think I'd like better than 2? Well, 0 is a good. Why is 0 a good one to pick? It's easy to substitute in. So why don't I, since I've got 0 here, let me just plug in a 0. If I plug in a 0 there, okay, that just means this x goes away. What's negative 1 squared? 1. What's 1 times 2? 2. What's 2 plus 1? 3. 0, 3. So I know that the point 0, 3 is on the graph of this parabola, okay? Now the minute I know that that point is there, there's another point that I know without even plugging in. What is it? Yeah, the point 2, 3 has to be there. So I'm not going to go, you can go through the work of plugging it in, but you don't have to because this graph is symmetrical, okay? Now I got to pick another point. I'm going to pick, I could pick negative 1 or I could pick 3. Which of those points would you rather pick? I'd rather pick 3. Why? It's positive. I'm not going to make the mistake with negative numbers. So let's put in a 3 here. What's 3 minus 2? 1. 1 squared. 1. 1 times 2. Wait, I already did that point. Wait, 1. Did I do that right? 3. Oh, sorry. Back up. What's 3 minus 1? 2. 2 squared is 4. 4 times 2 is plus 1 is. See, you guys are on shed of me there. So 3, 9 is right here. So the minute I have this point, I can go backwards over here, and I know I have a point right here. They have to be symmetrical. So there's no reason to plug that number in once you get a number on one side. So now I'm ready to graph this. So I know that it goes just like this, okay? And that should be it. What is the domain of this function? Yeah, the domain of every one of these is negative infinity to infinity, so please do not miss that, okay? The domain of this guy is negative infinity to infinity. What is the range of this function? Not 0, 1. The range is 1 to infinity, okay? Yep. Mhm. Okay, so I know that this thing is symmetrical. So the minute I know that this point 39 is here, it's 2 away from the axis of symmetry. So if I go 2 to the left of the axis of symmetry, I also have to get the same value. So that number, I can check it, that number is negative 1. If I put in a negative 1 here, negative 1 minus 1 is negative 2, negative 2 squared is 4, 4 times 2 is 8, 8 plus 1 is 9. So you don't have to do the work. You can, but you use the symmetry. So all I really needed, if I found 2 points, I really knew 4 points on a parabola, okay, because you're using the symmetry for that, okay? So let's take a look at another one here. I want to graph, let me make this a little bit smaller. Y is equal to negative 2, x plus 2 squared minus 1, okay? What is the vertex of this parabola? Yeah, the formula is, remember the formula is y equal a x minus 8 squared plus k. The formula has a minus built in. This x plus 2 is x minus what number? X minus negative 2. Okay, so this vertex is negative 2, negative 1. Okay, that's one of the big things that people miss. The formula has a minus built in. So you want to be able to write, this won't be given to you on the test. You'll need to know that formula, x minus 8. That's x minus negative 2. Does this parabola open up or down? Yeah, it opens down. Okay, what is the axis of symmetry? X equal negative 2. It's equation of a line. X equal negative 2. Yes. The negative in front. Okay. So let's look at it. So if I look at it, I know that the vertex is negative 2, negative 1. So negative 2, negative 1. There's also, that's also my axis of symmetry. X equal, wait, did I do that? Yeah, negative 2. That's my axis of symmetry. Okay, I know it opens downward. I just need a couple of points here. Okay, so I'm going to pick a couple of points on either side of the parabola, staying close to the parabola. Let's pick negative 1. So if I've got y equal negative 2, x plus 2 squared minus 1. If I put a negative 1 in here, what's negative 1 plus 2? 1. 1 squared is 1. What's 1 times negative 2? Negative 2. What's negative 2 minus 1? Negative 3. Okay. Let's pick 0. If I put in a 0 here, this becomes what? 2. 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 minus 1 is negative 9. So I know that the point negative 1, negative 3 is on the graph, and 0, negative 9 is on the graph. Once I know these 2 points, I don't even have to know what this point is. If this point is 1 to the right, there's a matching point that is what? 1 to the left. If I'm down here and this point is 2 points to the right, there's a matching point where? 2 points to the left. So I don't even have to go through the trouble of knowing what those points are. I know they're on my parabola. Okay. So you could plug those in. I could plug in a I could plug in a negative 3 and I should get a negative 3, or I should plug in a negative 4 and I would get negative 9. But I don't have to do that if I can just use the symmetry of the problem. Yeah, I mean, your instructions on the test may be draw the vertex and label the axis of symmetry. It's helpful because then you know how, in terms of the plotting of the points. So what we did, we plotted a couple points on one side of the axis of symmetry. What's the domain of this function? Yeah, please don't miss that one. What's the range of this function? Nope. Yeah, range is from negative infinity up to negative 1. Okay, so the range is negative infinity, negative 1. Let's go. Okay. Okay, let's take a look at this next one here. So what's the vertex? Yeah, negative 3, 0. Okay. If I get it in the form y equal a x minus h squared plus k is 0 here, and this is x minus negative 3. So it's negative 3, 0. So my vertex is at negative 3, 0, which is right here. Okay. What's the equation of the axis of symmetry? Yeah, x equal negative 3. It's just the x value of the vertex. Okay, so there's a line going through the x value of the vertex. Does this guy open up or down? It's going to open down. Starts with a negative. Okay. Now, a couple of choices of the way to do this. You can plug in a couple of points on either side, get the mirrored points, you're good. The other thing that you can do is if I look at x squared, so if I look at y equal x squared, okay, everyone agree that one started out at 0, 0, right? What happened when if I go over 1, how far up do I have to go in this graph? 1, okay. If I go over 2, how far do I have to go up? 2 squared is 4, right? So to get something like this, so this was over 1, up 1, over 2, up 4, okay? So I know that's what this graph looks like, okay? So what I can do, I can look at this graph and say, okay, all this graph is that same parabola moved, okay? So normally, I would go over, if this were x squared, I would go over 1 and up 1, okay? If it were x squared, okay? But it's not x squared, it's multiplied by what? Negative 1/2. So you can do something like that. You can say, normally I would go over 1 and up 1, but I'm multiplied by negative 1/2, so I'm going to go over 1 and down, not 2, 0.5, multiplied by 1/2. Now, does that feel intuitive, or does that feel like, I'm not sure what you did there? Okay, would you rather plug in the point and go from there? Okay, maybe when you get more comfortable, we can do this, okay? So what I want to do, I need a couple of points. I'm sitting here at negative 3. I'm going to pick things that are close to negative 3, and I tend to like to go close to 0 because the numbers get easier, okay? So let's just say I've got y equal negative 1/2 x plus 3 squared, okay? So if I'm sitting at negative 3, let's see what a negative 2 does for me, okay? So what happens when I plug a negative 2 in here? What's 3 minus 2? 1. 1 squared is 1. 1 times negative 1/2 is negative 1/2, okay? So negative 2, negative 1/2. So right here is this point, okay? Now, let's pick another number. Let's pick negative 1, okay? So if I put in a negative 1 here, what's 3 minus 1? 2. 2 squared is 4. 4 times negative 1/2 is negative 2. So negative 1, negative 2. Now, the minute I've got these 2 points, I'm done. And I also know what? There's a point right here, and then there's a point right here, okay? Sorry, this last one. If I go over 1, I've got this point, and if I go over 2, I've got this point. So this is my graph. Okay. What is the domain? Negative infinity, infinity. What's the range of this guy? negative infinity to 0. Okay. So negative infinity to infinity, negative infinity to 0. And one more, and we are done. Okay. What's the vertex of this guy? Yeah, -4, -5. Does this thing open up or down? Okay. So the question was, how is it -4? My formula is y equal a, x minus h squared plus k. What I'm faced with here is y equal 3, x plus 4 squared minus 5. That's the same as y equal 3, x minus -4 squared minus 5. The formula has a minus built into it, okay? So if the vertex is hk, this is x minus what number? This is x minus -4. So the vertex is -4, -5. So what you can do when you look at vertex form is you look at this number right here and you take the opposite, okay? That's a +4, my vertex is -4, -5. If that had been a -4, my vertex would be at +4, okay? So the vertex is -4, 5. This opens, what did we say, up. Axis of symmetry is a line what? Yeah, x equal -4. So -4, -5 is right here. That's also my axis of symmetry. This guy opens up. I just need a couple of points, okay? If I'm sitting at -4, I'm going to pick things that are close to -4, like 1 away or 2 away. So I'm going to go with, say, -3. And so we'll do -3 and -2. We'll plug those in. Okay. What happens when I plug in a -3 here? What's 4 minus 3? 1. What's 1 squared? 1. What's 1 times 3? 3. What's 3 minus 5? Yeah, -2. So -3, -2 is right here. The minute I have that point, I know there's a matching point on the other side of that axis of symmetry. Okay. Let's look at -2. 4 minus 2 is 2. So 2 squared is 4. What's 4 times 3 is 12. 12 minus 5 is 7. So -2, 7 is right here. The minute I know that point is there, there is a matching point right over there to the left of that. And this one is a sort of a skinnier parabola. And that is it. Okay. The domain is -infinity to infinity. What is the range of this parabola? -5 to infinity. Okay. And we are there.